Super cool. Momentum. Momentum. Okay, next example that we got is how do we define average speed with an example. So average speed is defined as followed. It is the change in position divided by the change in time. So if I change my position by 100 kilometers in 1 hour, well, I would have an average speed of 100 kilometers per hour. If I actually don't move at all, and I basically just sit in my chair, not moving at all for 10 years, well, I'm going to have a 0 meters per second velocity, or average speed, because, well, I didn't move. So this is how we define it. We look at the change in position and divide that by the change in time. Okay, so let's actually run this through with an example. Yeah, I guess what they have here is the example that they have here is it's also dependent on what is already known. So if you only know positions, so let's say when time is equal to 1 second, my x position is equal to 5 meters, and when time is equal to 20 seconds, my x position, I finished a 100 meter race. So x equals 100 meters, and I got a head start, or maybe at time equals 0, I was at the starting line, and 1 second deep, I was 5 meters in. 20 seconds later, I finished the race. It's pretty slow. I think I could do that faster in real life, but just for the sake of the question. So the change of position is going to be, let's actually give that like t1 x1, t2 x2. So it's going to be like x2 minus x1. That's the change in position divided by the change in time. T2 minus T1 equals 100 meters minus 5 meters divided by 20 seconds minus 1 second. So it would be 95 over 19. 95 divided 19. In this case, I would be a solid 5 meters per second. Okay, that could be an example of how you get the average speed if you're given the positions, only knowing the positions. You don't necessarily have to start at 0, but you could scale it to be at 0 if you incorporate the proper amount of factors and offsets. But if you know the speeds, you would take the average as if you would take like the average position. Like if you'd spent knowing speeds, you would take the average like anything else. So let's say for 5 minutes I was going 10 kilometers per hour. For 10 minutes I was going 100 kilometers per hour. Well, it would be like you would take the average that way. So we can do that as an example. So x going 5 meters per second for 10 min, then 20 meters per second for for 1 minute, average speed would be, well, it would be 10 times 5 meters per second plus 20, or it would be 1 plus 1 times 20 meters per second. Divide that by the total of 11 minutes that we were driving. And we would have something like this. So it would be 50 plus 20 divided by 11. Divide 11. And we get like our average speed is equal to whoops, 70 divided 11 is going to be equal to 6.36 meters per second. Okay, and that makes sense that it's going to be a lot closer to 5 than it is to 20, because we've been going at 5 for legitimately 10 times longer than we've been going at 20 meters per second. Okay, so that would seem like a reasonable answer if for a situation like this, and you're you know, averaging the known speeds already. Yeah. So the above solution is good. Is good. Question is a little vague in stating what is known already before calculating the average speed. Okay, cool.